And our last measurement is the measurement of time. So now we are talking about time, and time is measured in years, months, days, hours, minutes, and seconds. But the SI unit of time is the second, and the symbol is an S. Okay, so most clocks use a repeated motion of the swing of a pendulum, which is what we call oscillations. So a period of an oscillation, or just period, will be the time taken to make one oscillation. Now, what is an oscillation? Let's look at this grandfather clock over here. In this grandfather clock, some of you may have seen it before. Basically, it keeps time by the swinging of this pendulum over here. Tick tock, tick tock. It just goes left and right, left and right, left and right. Now, one oscillation would be from this point, from one side, going to the other side, and then back. They will most commonly ask you to write down the period, or ask you to find the period of an oscillation. This is mainly done in practical studies, which is the time taken for it to go from one side to the other side and then back. People who don't know how to do it properly will say, "Oh, I just time the time taken for the pendulum to go from one side to the other side and then back, and that's how I get it." This is completely wrong. Now I'm going to tell you the full procedure for getting the period from a pendulum timing. Let's say you are asked to find the period of a pendulum. You don't say it just goes from left to left and you time this. This is very, very inaccurate. What do we do to increase the accuracy of this timing? So the first thing we can do is to get a timing for 20 full oscillations, which means it must go from left to right, and this must be done 20 times. You switch on the stopwatch when you see it swing over here. So on, 1, 2, 3, 4, and on and on, all the way until it gets to 18, 19, 20 and stop. So after this, you repeat this getting 20 full oscillations timing 3 times. So basically you repeat step 1 3 times. So now you've got 3 of these timings, right? You get the average time for these 3 timings. This would reduce your random error. Now, this is not the end. A lot of people stop here and they don't continue because what you have gotten is the average timing for 20 full oscillations, but we want the period. And the period is the time taken for one oscillation. Therefore, now we will divide this average timing by 20, and this will get us the time of one oscillation. Now, they may ask you, can we make the pendulum swing faster or swing slower? Is it possible? Then do we change the size of the bob or the weight of the bob? Now, the only thing that changes the period of a pendulum, right, which is the time taken for it to swing one oscillation, the only thing that affects it is the length of the pendulum, which means how long it is. Okay? Nothing else changes it. The mass of it doesn't change. It can be 1 kg or 1 gram. It will still swing with the same period if the lengths are the same. Okay? Yeah. So to get a shorter period, to make it swing faster, like okay, you should get a shorter length of pendulum. Therefore, then to get a longer period, which make it swing slower, which is like whoa, whoa, whoa. Okay, then you need to get a longer length of a pendulum.